All right, so before we get into any more complicated lessons, let's clean this code up a little bit so it makes more sense. Right now, we're using very arbitrary names, and that's not helping anybody out. So let's call this one write log. So that's not a great naming convention, but I'm just going to use it for now for simplicity's sake, and we're going to say generate string. So this makes it easy. Commonly this is a way to do it, but I want to just make sure it's very clear what we're using and why we're using it. So let's run this program. What does it do? Absolutely nothing, because we just have a subroutine and a function that doesn't do anything. So what happened? The important thing to keep in mind is this generate string doesn't actually do something on its own. All it does is return a value. Now where it returns the value to is up to the developer. So in this case, let's go back and go all the way back to the first lesson and define what a variable is. A variable is a placeholder in memory. So x is 1. That's a value. You can also assign a value based on a function. So again, the whole point of a function is that it returns a value. So if I say generate string, like this, did I use that right? Yeah, generate string, and I say hello, and feed it a number, 1, we can see that this generate string takes in a word, hello, takes in a number, 1, and then adds 10 to that number. As you can see here, the number is now equal to the number, which is 1, plus 10, which is 11. So this is pretty confusing to beginning developers, because we were all taught, in grade school, 1 plus 1 equals 2. In the programming world, 2 equals 1 plus 1. It's the exact same thing, but it's interpreted from right to left. That can be pretty confusing at first, but it becomes second nature, like all these things, if you've done them enough. So what we're hoping for is that this function generates string, takes in the word, takes in the number, adds 10 to that number, 10 plus 1 equals 11, and then prints the word, the space, and then converts that number into a string. So it says word space and then the string representation of the number. So what do we do when we run this? Absolutely nothing. Why? Because all we've done is assigned that value that's generated to this variable x. We actually have to do something with x, so print x. So if now when I run it, hopefully it'll say hello space 11, and it did. So now we can start to understand how we can use variables to assign values from function, and then use those within the logic of the code. So let's create a new for loop. Here, I'll leave this all behind just for reference for now. But we create a new for loop. So for, and again, x is just the common go-to, so forgive me if I'm reusing that. But for x in range 0 to 100, which is again 0 to 99, which is 100 things, we want to be able to print something out. So we should talk a second about scope. So scope is a very complex idea until you understand it. Basically, scope is, and I'll put it right up top, scope is where something can be reached from. So from the base of this document, this is a global scope. Anywhere that's not inside a subroutine is globally defined, meaning it can be accessed anywhere. So to give you an example, this write log, I'm going to, let's call it write something. I'm going to use a global variable, and I'm going to call it G. It's not a great naming convention, but kind of G equals, well, actually here's a good one, equals 3.14. So we know that globally we have a variable called pi, which is the value of 3.14. This is an excellent example of a global variable, because we know it's something that can be useful in many places, and so it's accessible globally. So if I say write something, and we change this around and just say write pi, and we get rid of everything else. We now know that we have, and here I'll even make it, do a little section here. We'll call these global variables. And so the scope here is global, meaning it could be reached anywhere. So if I write something after I've defined it, it should print out pi. You see how I define a variable and then I defined a subroutine. That subroutine fires the print function, and that print function always writes pi. So, and then I actually call that print subroutine. Sorry to mix lingo up, but write something. So what it should write is write something, prints pi. Pi is 3.14. So hopefully when we press run, it'll say 3.14. Amazing. So if we wanted to print pi a lot of times for x in range 0 to 99, we just, and again, it's a little bit of formatting. Always remember that colon. Always remember that tab. Otherwise, it can't interpret it properly. So now, what is it going to do? It's going to write pi 100 times. Sure enough, there it did. So now we can start to do something a little bit more complex. So going back to what we did, write something, takes in a value, and then prints that value. So right now, if I run this, what's going to happen? Hopefully you recall that it's going to require that argument. I should clear this each time. That's a little confusing. Write something is missing the argument value in line 21. 21, write something doesn't have the parameter value. The value needs to be specified. So again, I can recreate that by feeding it a number right there. So if I run it, it's going to do exactly what it did before. Not very useful, but we can do more with it than just printing a value. We can actually do logic within the value. So let's say times x. So pi 3.14 times 1 times 2 times 3 times 4 100 times in a row. And now suddenly we're getting somewhere. So what does it do? Oh, here, let me clear this out. That's confusing. So run it. And now we're starting to get some crazy values because it's actually multiplying it by 1, by 2, by 3, by 4, by 5. So we're starting to get more and more complex things going on here. So let's build on that in the next lesson.